cost of solar, you have a lot of cost for the modules, for the inverters, for the equipment, for the construction of the plants. That's also labor, but it's all upfront investment, right? So once the plant is sitting there and running, you have a little bit of operations, you basically count your revenues, but not much anymore, which is very different for fossil fuel-based energy generation, where you also have a bit of capex, right? You have to build a plant, but then continuously, while you operate these plants, you have to pay for the coal, for the gas, for the oil, for whatever you burn. So the cost structure looks very differently between these types of technologies. Right? For fossil fuel-based power plants, if you look at the life cycle cost, average something between 80–85% is operating expenditure. It's fuel and O&M. Whereas for solar and wind, it's more than half. It's really the upfront investment, the capital expenditure. Little bit of OPEX, but then the capital expenditure also has to be financed. Right? So in the life cycle cost, you have the cost of equity, the expected return from the equity investors, the cost of debt, the interest rates that you have to pay on debt. Which have two consequences. If you move from this world to that one, you need much more investment. Right? You need huge investments. And the financing cost, that really matters. So what is your cost of equity and what is your cost of debt has a much bigger impact for the clean technologies compared to fossil fuel-based technologies. And that's not just for power generation, it's in other sectors as well, because generally the idea about a lot of low carbon solutions is that you burn less fossil fuels later on, either by switching to something which requires upfront investment or by being more efficient, which also requires more upfront investment to save it. So you have this. So that's the first reason why finance is so important. The second, also not in the nature, but in the status of technologies, is that a lot of technologies that we need are new. Right? There's comparably novel, and novel technologies tend to be really expensive before they get cheap. If you look at solar PV, I'm sure you've seen these curves, probably also this week, learning curve among solar PV, which reduced since the 70s about 99% of its cost, right, with increasing deployment. That's also true for wind and electric vehicles, batteries to some extent. And we will very likely also see that for those upcoming technologies, if you want, like a lot of things around hydrogen, the hydrogen economy, low carbon freight transport, carbon dioxide removal, right? Direct air capture, that's something I work a lot on. So this will also become cheap, but before it's cheap, it's expensive and you have to buy down this learning curve. And that's why you need more financing if you're in a transition and you want to make new technologies. Economic. The third reason why we need much more investments in a low carbon transition is and we just discussed that with Nico. I like that a lot. It's where we stand in the transition, where unfortunately climate action has been so delayed in many instances that now a substantial proportion of the capital stock will have to be replaced before the end of its economic lifetime. Right. So this is the stranded asset, which is something done in capitalist systems, but it means you need more finance because you're building something even though the old stuff will still work. You haven't fully depreciated it yet. This is coal-fired power plants are an issue. This in some developing countries this is less of an issue because it's about building new technologies, but in the OECD it's an issue, and increasingly in emerging economies as well. Right there you have this huge fleets of coal-power plant where you wonder can we operate that? So that's three economic reasons. And the fourth one, why finance is very prominent, I would say, is more political one. And that is that finance, climate finance, how it's then often dubbed, it has been a very important political dimension from the beginning of the fight against climate change, I would say. Right? So if you look at the international climate negotiations at the top, starting with the Kyoto Protocol, this is the top left. I don't remember that time, but that already had huge discussions on finance and introduced the clean development mechanism, aligned on side with the Kyoto commitments. In Copenhagen, then 2009, that's a big failure. I remember that vividly. Finance that front and center, which left then led them to the creation of the Green Climate Fund in Copenhagen, which was the Copenhagen Green Climate Fund back then. In the Paris Agreement, right, it's very prominent in Article 2.1c, Article 9. Also in recent COPs, the discussions about the new collective quantified goals, the loss and damage discussions, it's always linked. So you cannot get typically in this COP discussions the developing country parties on board if you don't also talk about it. So this is more political reason why you don't see any global mitigation actions without financial transfer. And that has root causes. Of course, one of them is a very unequal distribution of per capita emissions. Historically, also the dynamics, right? If you look at China, which used to be very low, now it's above the EU, this kind of. And also linked to that, just briefly mentioning, is if you move from this more OPEX intensive to a more capital intensive energy system, that also has huge implications on global trade and on respective roles. So this is some figures on renewable energy investment flows between countries. And this also has political implications, and of course, because it's different countries that profit from these transfers or not. So that's four reasons why I think we have to care about finance in the low carbon transition. There's at least two consequences for modelers. So for modelers that could contribute, I think one is to answer essentially the question, okay, so we have this huge financing needs, but how big are they exactly, right? So what are the financing needs? And this is something which also integrated assessment models have been used for some times. This is a similar paper in that field, I would say. McCullum et al. Was a multi-model comparison published in 2018. So these numbers look differently if you do that now, but where you essentially can use integrated assessment models to quantify investment needs in different scenarios. Here they compared like the ambitious 2 degree, 1.5 degree with the NDCs at the time to get an idea of, okay, how much money do we reach that. In my opinion, to help policymakers, we often have to go one step further, probably not just comparing these scenarios and then having these big numbers. Sometimes that also helps, but put that into context, right? So one direction would be, I think, to think about what does this mean with respect to changes in investment flows, right? Where do we need more than we currently need? So where is there maybe a challenge for the financial systems in redirecting between sectors, between regions? For that, you can take these outcomes and then set that into perspective to the investment flows of the last 5 years or the past 10 years or so to see shares. We did that a bit in the meta-analysis, which essentially took these model outcomes. This is numbers for the European Union now, or for Europe, the European Union Plus. We're currently doing the same for G20 countries in the new pathways countries, where we quantified, okay, for like the climate neutral by 2050 for Europe, we would need about a 40% increase in investment between the recent past and what would be annually needed then. So it's quite a substantial increase. It's not terribly large. It's before it was about 1.3% of GDP per year for Europe. Then it's about 1.5. So it's feasible, but it's substantial. And then you can look at how does it look for different sectors. And one thing that we then find for Europe, for instance, is that electricity needs much more, right? So renewables need more, of course, than in the past. Conventional power plants need less, but what we need more is much more than what we need less, which is, I mean, in line with this idea of things being more capital intensive. This is one thing which arguably markets can deliver, but then what we also saw is that, for instance, energy networks and storage, right? So if you add that up, this is even larger increase than renewables. And this is something which quite some European countries also struggle with to mobilize in the current financing structures. Low carbon transport infrastructure was the bucket that stood out there, which is mostly rail infrastructure, because the European policy strategies foresee a lot of modal shift in the EU, like putting more stuff on rail for that you need. But this is mostly rail infrastructure on existing lines and increasing. So that's one way where you could go to somehow make these model results useful. I would argue there's more. You could also think about helping policy makers understand what type of finance do we need, right? Is that public finance, something which has to go through public budgets, or is that private finance, where we have to make sure that private financial markets can deliver that. For instance, we see the energy utilities, so I just put some random numbers here from studies. We see in the energy sphere that public and private sector utilities behave very differently. If we talk about private finance, very important question is which type of private finance? Is that capital markets, right? Is that just investment in stocks and bonds that we have? Or is it project finance, which we often see in infrastructure sectors, where banks have a much bigger role? Where, from a policy-making point of view, it's much more important to have conducive conditions for bank finance. What else did I put here? You can try to quantify what does it mean for change in international capital flows to somehow get an understanding how policymakers will judge things then depending. So that's one area to contribute this better understanding the financing needs in their startups. The second one, and arguably the more tricky one, is understanding the cost of capital and how it affects different solutions. And that's what I have on my focus. Now, what a lot of examples from various studies. So, how the cost of capital determines model outcomes. To start with, it's maybe the most obvious one. We have changing interest rate environments over time, right? So, people that somehow lived through the last 10 years or so saw continuously reducing interest rates in a super low interest rate environment, which is good for a lot of low carbon technologies because they're capital intensive, right? But with changing interest rate levels and changing especially long-term regimes, we have different cost of capital implications, and that changes the competitiveness of technologies. So this is from a paper that we published before COVID. In any case, 2019, yeah, where we thought about, okay, we were still in a super low interest rate environment. What happens if interest rates rise again? In the study, we had at the time, we had a flat scenario, and then moderated at the time what we thought would be very extreme, like interest rate increasing again to 4.5% within 5 years' time. Turned out it wasn't that extreme because we saw that, but it was still double the speed of increase. And if you assume that this is like very simple SUE level as possible electricity modeling, you see that in the different scenarios, the cost of renewables, even though you have the learning curve, and that's all in there, would actually rise again, right? Especially for onshore wind, where we don't have so much learning anymore as compared to solar, where we see still expected cost reductions, which also materialize. So that could increase again, and it could also move the competitiveness of renewables vis-a-vis conventionals. And I think that's the more concerning effect, of course, because they are less affected. New conventional power plants are less affected because they're less capital intensive. But even more so in a lot of developed economies, we actually have this game between building new renewables or keeping operating existing fossil fuel power plants, where you don't have much investment anyway, even less the efficiency. So that's one example how these changing interest rates over time can affect technology competitiveness. Further, the cost of capital, COC, they of course don't just differ over time, but they also differ between countries and they differ between technologies for a variety. So here again, I put some numbers just to show the magnitude of these effects, right? So this is onshore wind, solar, and then grid, non-generation sector. If you see between countries in this year that we pick quite some difference, like could be at 1 to 3% in countries like Germany and the Netherlands, 10% in India. Between technologies, we often see this pecking order that solar PV has the lowest cost of capital, which is the lowest risk. Wind onshore is higher, and offshore even higher. At least we stand there since solar became mature. If you go back 10 years, then solar was more risky than wind. Now it's the other way around. So we have these differences on a global sphere. This is from the Calcutta et al. Paper last year, which was a multi-model comparison of cost of capital effects. Often you can classify countries in 3 groups. You have somehow the West, Europe, North America, that have low cost of capital. Then you have the high risk cost of capital countries, which is Sub-Saharan Africa, which is was part of Latin America. And then you have East Asia, Southeast Asia, which to some extent approximates the low risk of the West. If you look at China, for instance, relatively low. And then you have some sticky high-risk countries, like India, for instance, where constantly over time you always see this cost of capital in the magnitude of 10%, which doesn't seem to be go down. So you have the sticky consequences between. 3 illustrations of consequences of these differences I want to show. The first one, simple one, starting with the cost of solar PV, which varies globally, of course, and reflecting that adequately in models is really crucial. So this is how I came also a bit to the topic back in 7-8 years ago, where I saw a lot of these type of maps. It was the time where we always had these studies, 100% renewable energy systems globally, and then having these calculations that showed that it's somehow feasible. Then you often had these pictures like that, which showed, okay, what's the level of electricity? Here blue is low, and so okay, it's really cheap in Congo, the Democratic Republic of Congo, and Sudan, and so on. It's really expensive in Central Europe and Switzerland, which I found it odd to some extent, because if you see where projects are being built, it's not there, but it's in the high-cost countries, and also investors, they won't go there. And the reason for these model results is, of course, that these models are very accurate in technical parameters, solar radiation and stuff. A bit less accurate probably in investment cost, but then they totally ignore differences in the cost of care. Right, so they ignore that it's more risky to build a solar plant operated for 20 years in the Democratic Republic of Congo, vis-a-vis Switzerland. And I think that's, if you accurately implement that, so that's what we show here, that's the cost of capital empirically, which is like 25% in Sudan, this period, and 3% in Switzerland. Then the ranking of technology really flips, right? So then actually solar PV is much more expensive in Sudan and much cheaper in Switzerland. And ignoring that, I find problematic it's a bit politically, because it somehow suggests that in these seemingly high-cost countries like Switzerland would be insane to build solar. It's much cheaper to do that in Sub-Saharan Africa, which is then always an argument that's also employed to argue against renewables in these seemingly expensive countries, even though it's wrong, right? It's a cheaper one. So that's one problem. And the second is it somehow also misses totally why very little solar is built in some world regions, right? So it's like, okay, why are they not doing that? It's cheaper. It's actually not. So it's important to reflect that adequately in models. Second example, and I picked that because it's a lot about equity. Also in the summer school, I understood is on electrification. Which is a big problem, a big topic in Sub-Saharan Africa specifically. You have some 600 million unelectrified still. A lot of modeling is done around that, right? Because luckily, since technological progress, how can we achieve electrification? We don't just can extend the grid, which is a very costly option, but there's things like mini grids that you have, right? And there's standalone system, solar home system, but also standalone system for productive uses, solar pumps, and so on. And modeling is done typically using these GIS-based models to somehow see what makes most sense in which area of the country, right? Is that a grid extension area? Is that a mini grid area? Is that earmarked for solar home systems and so on? This is one example. This then goes into the electrification planning. This is from Rwanda, and then funding is allocated there. And it's very important to earmark these regions, because if you don't know, does the grid extension come or not, then you don't go with your solar home system company and so on. Again, in these models, then you have technical parameters, but you also have to think about the cost of capital, which is very different between these solutions, right? So this is big infrastructure. This is kind of more consumer goods type of products who live for 3 years. So we put that in the leading model for electrification. And if I zoom again into Rwanda, then you see if you just ignore differences in cost of capital, the models would say, okay, mini grids, they are really most economical in a lot of reasons. That's also why a lot of the development aid is spread on mini grids, but we never see them coming. Like, it's kind of these recurring patterns that somehow it doesn't work. But if you actually consider cost of capital and risk, then you would see, okay, actually standalone systems there would be important. So this emphasizes, I think, the need to reflect that, and also to, if you think about policy solutions, to try to address the risk. So, and the final example I want to mention, that's a recent study in the context of PRISMA, is what about beyond power generation? Right, so I talked a lot about electricity now, and there's some literature which includes that. I put 3 papers here. So the one that was with Patagonis actually is not an IAM, but it's an energy system model from Gemini 3, the sub-model, where we included that for Europe, the cost of capital differences. There's this, where I also put a slide, the Calcaterra et al., the multi-model comparison of IAMs. There's another one from the UCL, Borgs, high cost of finance, and asset-light investment traps, but they all look at electricity only, right? Including our own work, so I'm criticizing our own work there to some extent. And if you look at global emissions, then you see, okay, electricity, it's important, right? It's about like 23% or so of the total, right? So there's big sectors which are other than that. And also electricity is a bit special in the sense it's relatively low risk compared to some of the other sectors from an investment point of view. So here that's a beta. So the common measure you have for the correlation of a sector with the total market risk, and you see, okay, electricity, that's actually the low risk, low cost of capital sector compared to a lot of industry sectors, like cement, iron and steel, which is not surprising. They are also closer tied to business cycles and stuff. So the cost of capital are much higher there. So actually, maybe it would be very important to also reflect the differences there. And also other part of the energy sector, like not just electricity, but hydrogen production, for instance. But it's very high cost of capital as of today.
What is unlevered beta?
Unlevered beta, it's the beta, but then corrected for the fact that different sectors have very different debt shares. Right, and if you have I don't know, 70% debt share in one sector and 30% in another sector, and then you want to take the beta as a risk measure, you have to correct for that. So otherwise you're comparing apples and so on. But we could also show the betas, not unleveraging them, then it would be a bit closer, then the message wouldn't be that stark. But I think the rank order is still the same. I mean, we had to unlever because the way how we calculated the WACC for these sectors. I don't want to go into too much details there, but that's.
What is this for a certain set of countries? Or?
This is global. This is global over 10 years. So how we come to the model implementation, how we solve that in this case is that we have an additive formula in a sense. You have a risk-free rate, then you have country risk premium, and then you have a sector risk premium for the equity side, and then sector-specific debt shares. Because if you estimate these betas for these sectors on a country level or region level, you very soon run in situations where you have very few data, where you have very few, because you need quoted companies which are liquid on stock markets over these 10 years to estimate the returns there. I mean, especially on a global model, if you then come to some world regions where there's very few companies publicly listed anyway, and then even more so in some sectors, it's really hard to get sector equity, to get sector-specifically equity risk premiums on a regional level. So the common practice now is to do that. Also, BIT, like fundamentally argued, the reasons why these sectors are different in risk, it's because they're different exposed to business cycle risk in a sense, and that shouldn't differ too much globally. That's also one of the arguments for the rules. Sorry, but went into a bit of detail. So energy sector, it's important share of emissions, but there's a lot of other ones as well. Then it's special in the sense that it's relatively low sectoral risks, and arguably also the abatement costs in the electricity sector by now, they are much lower than in other sectors, right? In industry, for instance, if you think about cement, steel, this is higher abatement. So that's why in this study, which is ongoing, it's not published, hopefully submitted very soon. We're interested in starting with the image model. We also want to do a multi-model. We just talked about this morning, multi-model exercise to use the image model to see what happens if we adequately reflect these differences. The image model, probably you discussed that with Mark or whoever this week. It's quite high resolution with respect to regions, right? We have the 26 world regions and also the sector technology granularity. We do two things. We do the simulation mode, which is kind of which policies are in place, what does it mean for emissions, and then also cost minimization for 2-degree scenarios, country and sector specific COC. And then we model a relationship between GDP growth and cost of capital. Based on statistical estimations from the past, if you grow GDP per capita, then you probably converge a bit in cost of capital, and that's what we want. And then we compare that to uniforms. And what we find is this shows emissions, and I think for emission impacts, the simulation results, they are most informative. Of reflecting these cost of capital differences as compared to not reflecting them. Having a uniform cost of capital, which is kind of the state of the art in most models, just the discount rate, which is constant. But the uniform discount rate we set at the average, at the GDP weighted average of the other ones, so that we don't have this is really just the differences of differentiating, not a differentiating plus a level effect. And then we see if we differentiate, we see more emissions at the current policies. This is globally, and then we just pick the high risk countries, and we see okay, the high risk countries, this makes up more than half of the total. We see them in the electricity sector. We see them a lot in the transport sector, even though the transport sector is not that investment intensive. We didn't even differentiate the cost of capital for the transport sector here. But the transport sector, of course, consumes energy. And if electricity becomes more expensive, then abatement in the transport sector through electrification becomes more expensive. And even more so with hydrogen. With hydrogen, we see a huge effect, right? Hydrogen is very, very risky investments today. And if hydrogen gets more expensive, then the hydrogen abatement options in the transport sector, also hydrogen-based abatement, think shipping, think aviation, and so on, becomes more. And so that's the effect we see with respect to the simulation. With respect to this 2-degree scenario, so the cost minimization, there we can look at, okay, the model reaches the 2 degrees more or less anyway, if we optimize for that, but what does it mean for mitigation cost? Right, so that we can show that maybe the models underestimate mitigation costs by not reflecting these differences in investment risk and cost of capital. And we do see that quite substantially. So for the world, this is the mitigation cost for a 2-degree scenario. This goes up by an average, I think, bit below 30%, the mitigation cost, especially in the second half of the century, if we reflect differentiated cost of capital as compared to uniform. And if we see globally, then this mitigation cost increase affects especially, if you look at the dark colors, the developed economies, the rich countries, the low cost of capital countries. Because if we differentiate the cost of capital, then mitigation in the global south or in the risky countries gets relatively much more expensive, right? Because that's where the high risk is, and that's why more of the mitigation burden shifts to the then relatively lower cost regions, which is the global north. Yeah, there's something.
Just a quick clarifying question. Is that jump then in extra cost there is is it mostly explained because right now technology costs for developing regions are assumed to be the same as developed ones because that's where you have the data?
No, technology cost is the same in both lines. It's just, do we differentiate the cost of capital, which is reflected in discount rate, or not? That's the difference between the dotted and the solid lines.
But the cost of capital ultimately makes the technology more expensive, right?
Makes, yes. It's higher, so you pay higher interest rates. So the technology costs the same, but you pay higher interest rates to finance the technology. And that makes it relatively more expensive in the high-risk countries. But we compare it to a scenario with a uniform cost of capital, which is the average of the other one. So on a global sphere, it doesn't get more. Like interest rates on a global average are the same, but they are differentiated now. Right? So it's kind of a different way to represent reality. It's not a different cost assumption, right? I would argue, just adding heterogeneity. Yeah, I think you.
So you are making
Sorry, SS. Yes.
And then you keep it until 21.
Yeah, but we have some convergence. So we assume the differentiation, but then if GDP per capita increases, and this is based on what I show here is SSP2, we also had other SSPs, but in SSP2, it like per capita GDP converges quite a bit, and then the cost of capital let's say, make an example, India, the marker for cost of capital for India goes down because of books, which is more external.
But not full conversion there.
No, not full conversion. And this is calibrated on the historical correlation of cost of capital and GDP per capita. That's how we do it. Yeah.
Only to understand what you did. So the case with differentiated cost of capital, does that mean that so we have a uniform case and then all the countries get their specific marker on top? Or is the uniform case something like a average of the differentiated case?
So second. So I mean, we started. I mean, this is with Harmsen and Sources is working on that, right? And that is involved. We started with like the baseline, what is an image, but then to compare apple and oranges here, apples and apples, we did the differentiated one, which is empirically calibrated. So that like just takes what we see in the data, and then we calculated a new uniform one, in a sense, which is the average of the other one GDP rate. Because we really just want to have the effect. What does it if we reflect this heterogeneity, right? We don't want to measure to what extent is this uniform assumption of reality or something, right? Which one could also study.
You can explain again why, if we have globally average thing cost of capital, why in both or in all regions the mitigation costs are rising? Is it because of different allocation? Region?
I mean, this is after the optimization. So generally, because of this heterogeneity, we from a let's say if we have a share of the cost, which is a financing cost, it's we can no longer just like just for this cost component globally, just allocate where we want to mitigate, but it makes a difference. And so we are less optimal in a sense. That's why it generally rises. That's why it goes up everywhere. If you
Right, even the high-risk countries, even though they have more share of the.
yes, so it's because they have so much higher, and I think this is comparing different models, right? So it's different representations of reality, and I think the one with the differentiated is closer to not the model but the actual reality. So in reality it's so much higher, right? And then quite some of the mitigation effort shifts to the global north, but still it's
And globally more expensive.
yes.
Yes.
You see here, I mean, this is the global number, and this is the high-risk countries. It's not that much what it goes up, right, in the high-risk countries. But globally, it's a lot. Yeah, and I mean, this is a to my understanding, a first effort to have this in like a lot of sectors. This heterogeneity, and this I think we hopefully see more in models. Good, maybe to move on a bit, and then we can discuss at the end. I don't have so much more slides. I want to show a bit now, like this was the 3 examples, how this makes a difference. Some work we did some years ago where we included some modeling teams and thought about if cost of capital heterogeneity seems to have such a big effect, why is that not reflected more in models? Why is that disregarded, and how could that potentially be overcome? And this is 4 ideas we came up with. It's a bit of speculation, but also a discussion. So one is, it could be there's a lack of awareness of the relevance of cost of capital. I think this is probably less a topic now than it was 10 years ago, because there's a lot of talk about it, especially for the electricity sector, it's included. The second one is what we heard from the modelers we talked to for this paper is that it's not really clear how you should differentiate cost of capital, right? So there's no clear best practice or template, because in principle you can always differentiate between all technologies, between all countries, and over time, and do a lot of sensitivities, but then it's just throwing stuff on it, right? And where does it actually make a difference? Because you can do sensitivities on every parameter, of course. And we tried to come up, so that you've seen it, we try to come up with this heuristic for determining, okay, when should you differentiate and when not? And that's essentially asking 3 questions. So do we expect significant differences between geographies considered? And that is the case if we have very different country risks, or if we have very different merchant risk exposure, for instance, in the power sector, right? So that means for a lot of analysis, for instance, if you do an EU analysis, this probably has less of an effect. I mean, there's some cases, and then when we did the paper, then we set very high cost of capital because we're still the aftermath prices. But this means, like, for global comparison, it's much more important. If you have GCAM analysis for the US, then no, you wouldn't expect differences, right? The second question is on the time scope considered. Is that about a few years that we analyze? I think then you really need current cost of capital estimates. If you think about decades or centuries, as we often do with IAMs, then it's more about different policy scenarios, expected macro trends. Then the question is, what do you assume as convergence on this kind of questions? And finally, with respect to technology differences, the 2 factors to consider why we should have very different cost of capital. I think one is the technology maturity. Right, we have very immature technology which have a high risk premium still, but which can then come down from a financing point of view with financial earning. And do we maybe have a big transition risk in some technologies? Right, so coal power plant investments now in the European Union, for instance, they probably would have paid quite a premium to be financed if there were any. So that's the second. Then maybe it's not in the models because data is not there. I think on that front, especially for electricity, we have a lot of cost of capital data that was collected during the last few years. There was a lot of empirical work done. Some of that is summarized here. So this is an outcome of the PRISMA project, which will hopefully be published in a month or so, when we have a data set which has like a lot of 700 data points globally. You see this is the coverage. So for some countries we have like 10, 20 also empirical studies. So I think for renewables, really the reason saying we have no data is no longer much of a reason. For other sectors, it looks differently. Yeah, and finally, it's not necessarily easy to integrate differentiation of cost of capital into models, right? So models don't often work that way as image in the simulation mode does, that you just assume a discount rate, but it's often endogenous, right? You also have things like a global carbon price, which is discounted and stuff. It's not so easy to get this differentiation in there if the interest rate is endogenous to in some way or the other. 12 minutes. Maybe I take another 3 minutes or so for the last chapter, and then we can ask any questions. Cool. So finally, this all treated cost of capital as a parameter, but I also want to get across this message that it's a parameter that policy can affect in many ways, right? So was the argument to treat that as a lever. Here we'll start with this one. It's a literature review. Widely from a PhD student did some years ago, where we looked at empirical studies focusing on the electricity sector, power generation, and grid. And we found some 45 empirical studies that evaluate, okay, what are determinants, what are the drivers of cost of capital, and try to cluster that in different levels. You see, okay, we have determinants of cost of capital on the macroeconomic level, but then also on the sectoral level, the energy sector, and the financial sector, technology, company, project level. And a lot of those are actually something which is more or less directly linked to policy. On the energy sector level, for instance, this is from a study from Carsten Neuhoff and colleagues, depending on how you design remuneration mechanism, that affects revenue risk, which then affects financing structure and cost of capital. For developing countries, there's been a lot of work within the UNDP along the de-risking renewable energy investment framework they developed, which tried to also then break down the premium in cost of capital, cost of debt, cost of equity that those countries pay as compared to baseline. I think they take Germany and try to link that to different risk factors, and a lot of them are really just policy levers, right? So it's the grid connection with the off-taker credit risk, currency risk, these permit risk, so kind of energy regulation. So that's one lever for cost of capital. On the financial sector level, we do a lot of work on that. You have a lot of financial policies that try to redirect finance flows by addressing the financial sector with policies to like low carbon parts of the real economy. There's in OECD countries one lever that should to be quite important for cost of capital is state investment banks, especially green state investment banks or government institutions. If you look at the data we could find in OECD countries was about 11% of all renewable energy projects had some green state investment bank involved. And even much more so in some risky countries, like in technologies like in offshore wind. More than 70% of all offshore wind projects had either the European Investment Bank, the UK Green Investment Bank, or the German KfW as a financier. And that is because the cost of capital was much lower than these banks. So that's a lever in OECD countries. In a lot of developing countries, multilateral development banks, through various ways of engagement, they can help a lot to get the cost of capital down. This is some numbers on how many energy projects through 2015, so it's a bit dated. I think now it's lower, but like in sub-Saharan Africa, 60% of all renewable energy projects to that date that had debt had some multilateral development bank involved. Also 80% of fossil fuel-based power plants, by the way. Export credit agencies are increasingly important for renewables. So this is policy levers for the global south, which then potentially, and that's I want to close with that slide that I think some of you mentioned, the Calcaterra et al. Paper, could help the convergence of cost of capital, and this was this multi-model IAM study, which essentially assumed that the cost of capital in high-risk countries converges to the lowest country benchmark. And if you have that, then you would have substantially lower electricity prices and substantially more power generation from renewables. That's the green one here, a little bit less fossil fuels, especially in the high-risk countries, right? And these are, I think, the next step from this type of analysis to think about, okay, what are the policy, realistically conceivable policy instruments that could actually get this, get in the direction of this convergence, and how can we quantify that and then use models to show the impact of that. So I hope I got across that finance matters for low carbon transition. IAM-based analysis can help policymakers to grasp what needs to change, especially through the cost of capital as a parameter. And I think going the next step and thinking about how to reflect policy instruments that try to change the cost of capital would be even more helpful. Thanks a lot.
Thanks a lot, Björn, for this
very
comprehensive story. Also nice to see actually some results from our team that I hadn't seen yet. So I think it's been really, good thing. And like I said, I think it sort of encompasses everything that we basically know about finance. So we do have little time, but so again, I would say like two very important questions, and then you're here all day, I think, right? So,
yes, I'm here on the social thing tonight.
Okay, so any questions? Maybe. Yeah.
Are you aware of any studies studying the cost of capital in agriculture and maybe some impacts?
I'm not aware of much. I think it's a sector I don't know very much about. It's much less this investment game typically, right? So if you think about it, then maybe others know more what are the decarbonization pathways for these agricultural emissions. It's about demand, right? So to what extent is that more plant-based, maybe the diets and stuff. Then it's about agricultural practices and also things that you can do technologically, but they are less these upfront investment nature, and then later you don't have cost anymore. I think especially these anecdotally, what I know from the changing agricultural practice, they are maybe even more OPEX intensive. So my very preliminary thought would be that maybe for that sector, finance in the sense of investment is less relevant than for those sectors. But happy to hear other thoughts. I don't know.
We try to separate cost of labor and capital because we are planning to cost of profits. And then we were seeing some depreciation, I think 2 years or something like that, and then kind of like how every time step, like you would need to invest in new capital if you want to produce in a certain location, to avoid this relocation of production like easily, like the model to say like, okay, you still have capital here, you can not move so fast there, maybe it's more optimal state or just whatever. And then we didn't see, like, for example, large stranded assets or something like that. They were kind of like our appreciation assumptions were not, or were just like, I don't know, let's say, good enough for the model to decide just to relocate. So the costs were not so high, it was not really affecting things, but it was a very kind of preliminary check. So I was curious if you were aware of your studies.
Yeah.
But I understand what it's like.
I mean, I would imagine that you have in some areas, and then depends how rapidly do you adapt, right? Also globally, and with the relocation of agriculture production or not, or want to preserve the current footprint. And there's all types of motivations why you might want to do that, right? It's for jobs, but it's also for maybe a bit not autonomy, but less dependence on global markets and uncertainty and so on. I would expect that you, for instance, have more investment needs for irrigation and stuff. But then the models, yeah, they would show you how much more you need, but it's not these, then the irrigation investment is competing with some higher or lower emission investment. I think this is.
Last question.
So agriculture is one example, but there is like other sectors like transport and so on that and might be higher risk. How can we attract finance in those sectors where finance is needed, but there is risk so less activity for, I don't know, private financiers, for example, to step in?
Yeah, I mean, much of the work in this field and was what I talked about is kind of a technology competition within a sector, right? So we assume we have a transport need, like a shipping need, and then different technologies or different solutions. If you think about different sectors and okay, do we want to have more, I don't know, agriculture, and more investment into agriculture or more investment into I don't know, cement to build houses or so. I'm not sure if it even makes sense to try to incentivize that via the financial sector, via somehow trying to manipulate cost of capital in that areas, as compared to real economy policy interventions, right? So just taxing the consumption in a certain sectors or subsidizing the consumption in other sectors. So I think that would be my first thought. I think using finance as a lever, one always also has to be aware of the limitation. Think about, okay, where does it make sense to go through the financial system and financial parameters to change something, and where should we actually address the real economy, right? And I think this between sectors, and that's what a lot of governments do. They subsidize agriculture, right? Because you have reasons that you want to subsidize that. I think I would rather do that through real economy interventions as compared to financial economy interventions.
Okay.
Good.
Thanks again. Yeah, so we have lunch on the other side of the street again. It's actually the next door next to the restaurant where we were the day before yesterday, right? So yeah.